Here's a short video entitled Sunrise Ranch Storm and Wastewater Project Overview. Sunrise Ranch is an intentional community and conference and retreat center located just west of Loveland, Colorado. We graze beef cattle on pasture, rotate chickens, pasture-fed chickens, and have large gardens, and we're a community striving toward a regenerative approach toward managing our land and our resources. We water our pastures and our gardens with irrigation pipes that come, and we get our water from a feeder canal, part of the Big Thompson Water Project, called the Hansen Feeder Canal, that brings water from the western slope of Colorado, from Lake Granby to the Front Range. A little bit about stormwater, one of our design considerations. Here's a couple of primary watersheds that flow through the community, and I want to speak specifically about this area here, where there's a large collection of water that comes down from the mountain during a large storm or the big event, and funnels into the community. All of that water comes down from the mountain, and it comes through a little culvert under the road, through the community this way, and down this way, and also down this way. And so during a heavy rainstorm, there's a lot of water that runs through a creek bed that is dry most days of the year. This water continues down the creek bed, and right about here is diverted through a little diversion canal to come around and re-enters into the watershed here. The purpose for this diversion canal is to prevent any stormwater from entering into our wastewater polishing pond. And the reason we want to do that is because there is no outlet designed for this wastewater pond, and if ever that pond were to fill up beyond its capacity, the low point for that pond is located right about here. And so water would breach this bank and flow into the garden this way, something that could be quite hazardous and something we want to avoid. So we want to divert the wastewater around this way. The issue is that when a heavy rainstorm comes, this creek bed is not of great enough capacity to contain the water, and the water overflows, and a couple of places where it overflows are here, comes into the garden this way, and also over here this diversion ditch is not of great enough capacity, and so a lot of the water flows out this way and covers the landscape over here. So I have a short video that was taken during a heavy rainstorm, and you'll see the water breaching the riverbank or the creek bed and flowing out into our garden. So as you can see, it's flowing over the bridge, and the normal route of the canal is this way, and yet it's moving this way. A lot of water coming down. Again, all of the water at the top of the screen here has breached the riverbank and is flowing into our garden. This creek bed is a few feet deep and not quite large enough. Here's a topographical map that'll be of great utility when designing a stormwater management plan. And a couple of things I want to quickly point out here is that this pond is designed at a key point in the landscape, and if we follow the key line across this way, there's another key point here in this pasture, something that could be very useful when managing stormwater. So moving on to wastewater, all of the community effluent is collected in this primary aerated lined lagoon, and when it reaches a certain capacity or a certain volume, there's a discharge into this unlined polishing pond where all of the water either evaporates, is drunk up by these trees and transpired into the atmosphere, or seeps down into the aquifer, or into the groundwater. A couple specifications about these lagoons. This primary lined aerated lagoon has a capacity of 158,000 gallons, and with 65 residents, the annual average day flow is 8,500 gallons per day, with a peak day flow of 21,000 gallons per day. And the capacity of both of these lagoons together is 270,000 gallons. So here's a couple of dimensions: 55 by 55 feet here, and 65 feet wide at the narrow end, 173 feet wide at the long end, and 240 feet long. One of the primary purposes for considering wastewater is because the EPA no longer considers this style of wastewater management as meeting state requirements, and the reason is because this unlined polishing pond is potentially leaching excessive amounts of nitrogen into the groundwater, thus contaminating it. And so they're wanting us to redesign the system. In addition to that, I think that it's a good idea to redesign the system because currently this aeration pump used to aerate the water and feed the aerobic bacteria and biology that helps to convert some of that nitrogen into vegetation and biomass is a very energy consumptive device. And so if there was a way we could lessen the energy requirements of this wastewater system, I think it would be in our best interest. So another requirement of the health department, the state health department, is to install an upgradient and downgradient monitoring well to determine how much nitrogen essentially is being leached into the groundwater table. Our current approach to these issues is to install a sequencing batch reactor, which is a single train system which incorporates a constant level anaerobic selector chamber followed by a surge tank and one or more sequencing batch reactor basins. Influent enters the anaerobic basins where solids are allowed to settle. The system reduces waste sludge by up to 75% for the entire secondary process. The influent then flows to the SAM surge basin, which provides flow and nutrient equalization. Aeration and energy requirements are reduced as nitrates are fully reduced into nitrogen gas in the SAM tank. So this process would meet the requirements of the health department and is a fairly standard way of approaching the issues that we're facing here at Sunrise Ranch. However, there is still an energy requirement, and there is not a high aesthetic value to this system, nor does it create habitat for any wildlife, and nor does it make use of any of the potential nutrients that may be contained within the water. So a potential alternative would be a constructed wetland, which uses gravity to move the water through it, plants to clean the water, and creates habitat for wildlife. It has an aesthetic value among many other benefits. In 20 years, we may grow up to 100 residents and have to design a system that accounts for an annual average day flow of 13,000 gallons per day. And so these are all some of the design details or the design constraints and requirements for this project on the horizon for Sunrise Ranch. And if you are a designer, or have a design company, or are a student of permaculture or wastewater management, I encourage your input, and your participation in one way or another in this process.